Good evening, everyone. My name is Akhilesh Rathi, and I'm a student of Masters of Professional Engineering, major in Mechanical Engineering. I'm here to present my presentation on design and analyzing a hybrid energy system for Mawson Base located in Antarctica. In my presentation, there is introduction, background, solution, outcome, impact of the project, time frame, and summary. Coming on to the introduction. Fossil fuel is something that is like the lifeline of the industrialized world, and we can't neglect the fact that the globalization has brought the modern world into something where they require a rapid energy consumption. And to fulfill that energy consumption, fossil fuels are the main source right now. And the byproduct of the fossil fuels is not really good for the environment and not for the mankind as well, because it causes deadly diseases like asthma, cancer, etc. Also, fossil fuel takes millions of years to replenish, so we can't rely on it because they are finite, and in future somewhere these resources are going to vanish. There is another resource, that is nuclear power plants, but still nuclear power plants are not into a situation that we are going to reuse them at the very wide range, because there are two different schools who are fighting for in and against the renewable resource generation. There is also another resource which is renewable resources, which consist of wind, solar, tidal, etc. These resources are quite eco-friendly, and they are sustainable resources. They are with us, and we can call it a gift of Mother Nature to all the human beings living on this planet. So we don't need to worry about them to get replenished, because they are already existing on this very earth. Now, if we see the global consumption from 1800 to 2019, there is a dominance of fossil fuels like gas, oil, and coal since 1800 till now. In 1920, the gas as a power generation came into action. But after 2 decades, in 1940, the first hydropower plants came into action. This is the year when the renewable energy took birth, and since then, wind mills and solar power plants has joined to produce the electricity. There are different resources as of now, but still there is a dominance of fossil fuel in the global consumption. If we look at the pie chart of global direct primary energy consumptions for 2019 in percentage for 2019, we can see that the 86% of global consumption is still produced by fossil fuels, which is very high comparison to the 12% produced by renewable resources and 2% produced by nuclear power plants. So all the countries are investing a lot in their renewable resources power generation, and Australia is among those countries. It's one of those countries. So this is the Australian energy statistics for 2017 to 2018. There's an annual increase of 1% in energy consumption for Australia, whereas there is a 56% generation of energy is still by coal. But the interesting fact is that the 21% of the total generation, electricity generation, is by renewable resources, out of which there is an increase of 46% in the solar generation from last annual report. Australia is consuming 21% of energy consumption was by oil, which decreased from the previous annual statistic report. And I've got this data from the Department of Industry, Science, Energy and Resources that they have published in 2020. The main objective of my project is to design and analyze an off-grid system, or a RAPSC system, that is Remote Area Power Supply System, for an isolated location with a specification of high renewable fraction, high power generation efficiency, cost effective, low emissions, and low maintenance cost. So if we talk about the remote area power supply system, only the renewable sources come into my mind, because those are the sources which integrate quite well with the remote area power supplies, because you will find them everywhere, and it's not like something you need a fuel transportation for your diesel generator or combustion engines. It is those resources are there, and you can utilize them if effectively. Now coming on to my study area, that is Mawson Base. Mawson Base is an Australian research base in Antarctica. It's one of the three research bases for Australia in Antarctica, and it's a permanent research base. That means it is inhabited by researchers throughout the year. The data coming from the Department of Agriculture, Water and Environment states that in winters there are approximately 20 researchers who inhabit the research center, and the population triples in this get thrice in summer, whereas there is more than 60% living in the center at that point. The closest mainland to Mawson Research Base Center is Perth, which is 5,300 kilometers away. There is an interesting fact about this research base center, that in 2003, this research base center became the first research base center to commission the hybrid energy system. And this is 2020. So in these 17 years, there is a technological advancement in both in the field of renewable resources. So somewhere down the line, their hybrid system is due, and I'm going to research and design a system considering the current scenario, and I'm going to try and design something which is more effective and could be commissioned, could be used in the Mawson Base Research Center. For this project, so far I have did a literature review on two different journal articles. One of them is by Parth Sharma Saini. They have wrote it in 2016. So they designed the RPS system for 11 villages in Almora district of Uttarakhand in India. They have utilized the geographical location quite well, as they have constructed a hydropower plant along with the solar panels, and they also engaged the local communities into their initiative, as they collected the biodegradable items and produced the biogas, set up a biogas plant so they could use that biogas for their cooking purposes and other household purposes. They have successfully produced the electricity that would light up the 11 villages. And one of the interesting facts about this literature review text is that they share the same load profile as of Mawson Base. So it is something that I could look forward while doing my project. So this is the one of the journals. There's another research article by Gann, Sheikh and Mueller. They have also wrote it in 2016. So it states the hybrid systems with the diesel generator. They have used a diesel generator, but they states that when you use a diesel generator with any hybrid system, there's a chances that regular on and off of a system, or a diesel generator or a combustion engine, can cause a wear and tear in the dynamic parts that will eventually affect the cost of whole project. So what they did is they did a MATLAB simulation for the combustion engine, that is this diesel generator, and they came in with the solution or with the procedure that could be used for hybrid energy systems and to produce a power by diesel generator in a more effective and optimal way. So the proposed solution for my project is designing a standalone system that is suitable for my location, study area, that is Mawson Base. And during this project, I will design different combinations of energy, of different combination of the systems, like 2 renewable resources or more renewable resources altogether, all non-renewable resources, or mixture of renewable and non-renewable resources, considering the different variable parameters like temperature, pressure, solar radiation, and wind speed. So because these all variable parameters will eventually affect my working of my hybrid systems, and it will also challenge me to design something which is suitable for all these parameters, and it will be something which I can use to evaluate and distinguish the different designs. As my designs are going to include wind power, solar power, and other renewable resources, along with the combustible engines like diesel, gas, or petrol. So this is something I'm looking forward to doing my project. The outcome of the project would be standalone systems that I will design an off-grid system for Mawson Basin in Antarctica. I'm trying to achieve a cost of electricity somewhere around 30 cents. On an average, an Australian person spends 25 cents to 40 cents per unit, per kilowatt hour on their electricity supply. And if I achieve 30 cents per kilowatt hour, that would be really good for my project. I'm also looking forward to achieve a renewable fraction of 80% or above. So renewable fraction is something that for how many hours your renewable resource is producing electricity. So I'm trying to achieve the efficiency of 80% or more in my renewable fraction. And definitely, if I'm using the renewable resources, there will be low carbon emissions, low nitrate emissions, and low sulfide emissions. So it will be a good solution for a greener planet, or that will lead to a greener planet. The impact of the project would be that it would encourage the research in the field of standalone system or RPESC systems. Involving the renewable resource in a hybrid system will lead to a greener Earth, as it will lower the carbon, it will lower the emissions definitely. And also the remote power supply systems could be used in at distance communities, at mine sites, research bases, and for the military operations where you can't take the off-grid, where you can't take the grid system to produce your power supply, or where the grid systems are getting very costly to produce the power. So it's something that will definitely impact of my project. Now coming to the time frame, I'm designing the project for up to 25 years, and for this time frame, I'm considering my model to have the following factors over the 25 years. That is initial cost, that how much cost we are going to put for the project. Operational and maintenance cost, like how many times does the system requires a scheduled maintenance, whether it's a minor or major maintenance. Salvages, capacity shortage, whether the system is producing high electricity or low electricity, or whether there's any shortage of electricity, and if there is any excess of electricity, how I'm going to use it, whether I need to use a flywheel or a battery system, or a combination of flywheel or a battery system to store the electricity, and replacement cost of the equipment. So when I have to replace the equipment, that's also a factor that I have to consider in my time frame. Summary. Now coming on to the summary, I will design an economical and sustainable solution with the low emissions. And definitely Mawson will get its energy independency by use of an off-grid system. So they will create their own small little ecosystem of energy that they will generate their own energy and will utilize it. These are the references that I have used throughout my presentation. Thank you. Any questions?